A megawatt electric motor has been designed by MIT engineers. It's said that this motor will power the next generation of electric airliners, as in commercial airliners. The future of something quite amazing is potentially about to begin. Hello, my friends, and welcome to the channel. It's great to see you. Thank you for tuning in. My name is Sam Evans. I'm the Electric Viking. Aviation's huge carbon footprint could be about to shrink enormously. Why? Well, because electric airplanes are about to be a thing. There's actually been some of the biggest airlines in America privately working on next generation electric airplanes. Now, they're not at the stage yet where they're about to actually commercialize them. They're a fair way off that. But using next generation batteries that have just emerged within the last 6 months, it's absolutely possible that this could happen within a few years' time. But they need the right motors. Now these MIT engineers, well, they have them. So far, unfortunately, only small electric planes or drones or those sorts of things actually do commercialized flights. And they happen a lot, in fact. There's quite a lot of commercial airplanes. They're electric, but they're small. Not big ones yet. Yet is the operative word. Even these small electric motors, though, generate hundreds of kilowatts of power. Think how much power, for example, is in a Tesla Model S Plaid. It's massive. But to electrify larger, heavier jets, such as commercial airliners, megawatt scale motors are required. These would be propelled by hybrid or turbo-electric propulsion systems where an electrical machine is coupled with a gas turbine aero engine. To meet this need, a team of MIT engineers are now creating a 1 megawatt motor that could be a key stepping stone, says Clean Technica, toward electrifying larger aircraft. The team has designed and tested the major components of the motor and shown through detailed computations that the coupled components can work as a whole to generate 1 megawatt of power at a weight and size competitive with current small aero engines. Meaning that basically these motors are more power dense than current motors in internal combustion engine powered airplanes. Much more power dense, in fact. It's not even close. For all electric applications, the team says the motor could be paired with a source of electricity, such as a battery or a fuel cell. I'm not sure about you, but I personally wouldn't be too keen on being in a hydrogen-powered airplane. Imagine the explosion that could occur. EVs, I guess there could be a fire, although they're much rarer than internal combustion engine vehicle fires. So I imagine that would be extremely unlikely. So how would this work? Well, the motor could turn the electrical energy into mechanical to work to power a plane's propellers. Pretty simple, really. The electrical machine could be paired with a traditional turbofan jet engine to run as a hybrid propulsion system, providing electric propulsion during certain phases of a flight. No matter what we use as an energy carrier, batteries, hydrogen, ammonia, or sustainable aviation fuel, not that there's such a thing, but anyway, the airlines like to think there is, independent of all that, megawatt class motors will be a key enabler for greening aviation, says Zoltan Spakovsky, the T. Wilson Professor in Aeronautics and the Director of the Gas Turbine Laboratory at MIT, who leads the project. Spakovsky and members of his team, along with industry collaborators, will present their work at a special session of the American Institute of Aeronautics and Astronautics Electric Aircraft Technology Symposium at the Aviation Conference in June. The MIT team is composed of faculty, students, and research staff from GTL and the MIT Laboratory for Electromagnetic and Electronic Systems. Henry Anderson, Yun Kang Chen, and a bunch of other people, including Mitsubishi Heavy Industries, are involved in this project. So are commercial airliners a problem? Do they cause much pollution worldwide? Actually, they do. It's massive. To prevent the worst impacts from human-induced climate change, scientists have determined that global emissions of carbon dioxide have to reach net zero by 2050. We can do it. We have to electrify commercial airplanes to make it happen. It is definitely possible considering the energy density of batteries today. Missing from this target for aviation, Spakovsky says, will require step change achievements in the design of unconventional aircraft, smart and flexible fuel systems, advanced materials, and safe and efficient electrified propulsion. Multiple aerospace companies are focused on electrified propulsion and the design of megawatt scale electric machines that are powerful and light enough to propel passenger aircraft. Of course, the weight is what matters the most, but remember the weight of the battery pack is the most significant contributor to the overall weight of an airplane. Now that we're seeing higher energy density from batteries, significantly higher, we pretty much have the majority of the solution. However, Spakovsky says there is no silver bullet to make this happen, and the devil is in the details. This is hard engineering. In terms of co-optimizing individual components and making them compatible with each other while maximizing overall performance, it's a challenge. To do this means we have to push the boundaries in materials, manufacturing, thermal management, structures, and rotordynamics and power electronics. Broadly speaking, an electric motor uses electromagnetic force to generate motion. Electric motors, such as those that power the fan in your laptop, use electrical energy from a battery or power supply to generate a magnetic field. Typically, this is through the use of copper coils. In response, a magnet set near the coils then spins in the direction of the generated field and can then drive a fan or a propeller. Electric machines have been around for more than 150 years. They're actually surprisingly similar. In fact, they came before internal combustion, with the understanding, however, that the bigger the appliance or vehicle, the larger the copper coils and the magnetic rotor, making the machine therefore heavier. So reducing weight's a challenge, but we've seen electric motors come down in weight as well as batteries come down in weight. The more power the electrical machine generates, the more heat it produces, which requires additional elements to keep the components cool. Now those add up in terms of weight as well. And these could take up space as well as weight, adding to the overall system. Now the thinking here is that all of this, it's all very new for airplanes. It's all quite a challenge because keeping the weight down is very, very challenging, even for today's airplanes. Heavy stuff doesn't go on airplanes, Spakovsky said. So we had to come up with a compact, lightweight, and powerful architecture. As designed, the MIT electric motor and power electronics are each about the size of a checked suitcase, weighing less than an adult passenger. That's insane. The motor is less than the weight is about the size and weight of a suitcase. That is ridiculous. Imagine if you could say the same about an internal combustion engine motor on a jet commercial airplane. They are way bigger and way heavier. The motor's main components are a high-speed rotor linked with an array of magnets with varying orientation of polarity, a compact low-loss stator that fits inside the rotor and contains an intricate array of copper windings, an advanced heat exchanger that keeps the components cool while transmitting the torque of the machine, and distributed power electronics system made from 30 custom-built circuit boards that precisely change the currents running through each of the stator's copper windings at a high frequency. I believe this is the first truly co-optimized and integrated design, Spakovsky said. This means we did a very extensive design space exploration, where all considerations from thermal management to rotordynamics to power electronics and electrical machine architecture were assessed in an integrated way to find out what is the best possible combination to get the required specific power to be 1 megawatt. As a whole system, the motor is designed such that the distributed circuit boards are close coupled with the electrical machine to minimize transmission loss and to allow effective air cooling through the integrated heat exchanger. And cooling, of course, is actually a little bit easier in a commercial aircraft than what it is actually in an EV to some degree, because, when an airplane is high up in the sky, say at 10,000 meters elevation, or about 28,000, 30,000 feet, the air up there is actually very, very cold. And that can help to keep things like motors cool. This is a high-speed machine. And to keep it rotating while creating torque, the magnetic fields have to be traveling very quickly, which we can do through our circuit boards switching at high frequency, said Spakovsky. To mitigate risk, the team has built and tested each of the major components individually and shown that they can operate as designed and at conditions exceeding normal operational standards. The researchers plan to assemble the first fully working electric motor and start testing it in an aeroplane this fall. The electrification of aircraft has been on a steady rise, says Philip Ansell, director of the Center for Sustainable Aviation at the University of Illinois. He said, and he wasn't part of this project, he was actually very impressed by it though. He said this group's design uses an incredible combination of conventional and cutting-edge methods for electric machine development, allowing it to offer both robustness and efficiency to meet the practical needs of aircraft of the future. Pretty high praise coming from someone who is basically your competition. Once the MIT team can demonstrate the electric motor as a whole, they say the design could power regional aircraft and be a companion to conventional jet engines until it fully takes off. It would enable hybrid electric propulsion systems, a little bit like a plug-in hybrid of what we have today. The team also envisioned that multiple 1 megawatt motors could power multiple fans distributed along the wing on future aircraft configurations, allowing them to be possibly fully electric. Looking ahead, the foundations of the 1 megawatt electrical machine design could potentially be scaled up to multi-megawatt motors to power larger passenger aeroplanes. Clearly, that is the way of the future. Electric aeroplanes flying through the sky. And one of the big benefits that I can see coming is the noise. Sit towards the back of an airplane and you can hear those engines roar. It's so loud. Imagine a silent electric airplane. The only thing you can hear is the wind. Then the engineers can really focus on just keeping the wind noise down, and you can have a perfectly peaceful and silent flight. One that doesn't spew massive amounts of emissions into the atmosphere. I'm looking forward to it. Let me know what you think in the comments. Thank you for watching.